Advanced Math Lesson 26, the logarithmic form logarithmic form of the exponential and then logarithmic equations. Now, logarithms are a really big concept to wrap your head around. However, the math is very simple, which is why logarithms actually exist. Hopefully I'll get enough time to talk about that in the lecture. The short story is logarithms were invented to deal with very big, large numbers, so that way they could be in a more manageable form, which is why the math is very simple, but the idea or the concept is hard to wrap your brain around. Once you can understand it, and the concept is well known to you, with the math being simple, these problems really are not that difficult, but they have a really long learning curve. They take a minute to pick up. So the first thing we're going to learn how to do is how to write exponential equations in logarithmic form. So we have to write this equation in log form. So the way logarithm works is it's just another way of saying that a base number like 3 to an exponent will give you a whole number value or a different number value. So all we're saying in log form is that if we were to take a log base of 3 and put it to the exponent of y, we would equal 4. So what we do here is we take the base number of the exponent, and that becomes the base of our log. And we write it as log base 3. And it makes sense to call it a base because it goes right at the bottom of the log. So we say log base 3 of 4, which means the answer, 4 being what number we're going to get when we apply the logarithm, equals y. So if we were to take the base number of 3, or the exponents of 3, the exponent of y, or if we put 3 to the power of y, would give us the answer of 4. Another way to think of this is this way. If you have it in exponential form, you grab the base number, you move it to the left, you put it down here, you add the log, and then y comes down and becomes a whole number, which is what you see right here. And then to write from logarithmic form into exponential form is the exact opposite. We're going to take our base number, log base x, and we're going to move it over here, and that's going to push this up into the exponent. So what we end up, and then the log goes away. So what we end up getting is we take 4, that's going to equal x to the power of m. So what we're saying is log base x of 4 is m. So the exponent of x to get the answer of 4 is m. That's another way to think of it. So there's a lot of big words, there's a lot of concepts to go over, but the math is very simple. It's just a really simple technique. If you have the exponent form, take the base number, pull it to the other side, put log in front of it, take the exponent, make it a whole number. If you have the log form, take the base number, pull it to the other side, take that whole number, move it to the exponent, leave the other number where it is. All right, annoying phone calls. Let's see here. Now we're going to move on to logarithmic equations, which we can use this method that I just showed you to help us solve. Let's see here. The first one, we have log base b. I'll just do this on the paper. Ta-da. Okay. So what we have here is an equation. It says log base b of 8 equals 3. So again, what we're saying is the log of the base number of b is going to give us an answer of 8 when we give it the exponent of 3. So we just take our number, we move it over here, this goes to the exponent, and we rewrite this as 8 equals b to the power of 3. Well, to figure this out, we just cube each side. 8 is going to factor into 2 times 4. 4 is going to factor into 2 and 2. We now have 3, so the cube is 2, which means the answer is 2. So b equals 2. There's two ways to deal with cubes. You can either memorize them, or you can use a factor tree, look for pairs of 3 instead of pairs of 2. Let's do another example. I'll write a couple of these because this is going pretty quick, and these can get pretty confusing. There we go. Okay, we'll start with the easiest one down here. Log base 4 of 8 equals x. Again, we just take the 4, move it over here, x becomes the exponent. We get 8 equals 4 to the power of x. From here, we just need to figure out 4 to what power equals 8. Now, this can be really tricky if we don't know about exponential notation. Now, when you get to numbers like this, where you get stuck and you think there is no answer, it's really easy. Both of these are multiples of 2. In fact, we could take 4, we could rewrite it as 2 squared, right? And then when we do that, we're going to go ahead and add the x on there, right? So that becomes 2 squared with the x. And then 8, if you know your cubes, can be rewritten as 2 cubed. Okay, from here we can go ahead and solve. And the way we can solve this is we use a really cool logarithm trick that we'll go into more detail later. But the short version is if you have 2 numbers to the same base, or 2 exponential numbers to the same base, we don't have to solve the bases anymore. All we have to do is solve the exponents. So once I have the same base, I can write those out. And I just have 3 equals 2 times x, divide by 2. And then x equals 3 halves. So this one, 3 halves. Now let's go up here. So that one's the easiest because all we have to do is once we get our whole numbers, just find similar bases. We got to write them in the same base number. Now these ones, these get a little tricky just because there's a lot of fractional exponents and weird things going on. So we'll start with this one. We've got the log of 1/3 of p equals -2. So again, we take this base number, push it up here. We get p equals 1/3 to the power of -2. Now, to make that a positive exponent, we're first going to distribute this exponent into the fraction because it gets a little weird that way. I mean, it's hard to look at and then you're not sure what to do when you bring it up to the top, right, of the fraction or to move it to the bottom. So that we can either make this 1 over 3 squared, and then that becomes 1 over 9, and then we can do the loop-de-loop, and then it just becomes 9. The other option is to just apply the negative to the bottom. So, well, yeah. Anyways, fractional notation works. That's probably the one we've got the most familiarity with. So we'll just stick with that one. So that one's 9. So when you get these fractional numbers to the exponents, just move the whole thing down to the bottom and then simplify as normal. Now this one, we have log base 3 of 1 over 27 equals m. So we'll take 3, we'll move it over here. And then we get 1 over 27 equals 3 to the power of m. All right, and then again, we're thinking we're stuck. I'm not sure what to do here. Well, let's see if we can write everything in a similar base number, just like we did over here with our whole numbers, right? If we can get them in the same base number, like we did with the 2's, we can solve it. Now, we know that 3 is divisible by 3, and 27 is also divisible by 3. Now, the thing we also notice with 27 is 3 is actually a perfect cube. 3 times 3 times 3 equals 27. So I can rewrite this as 1 over 3 cubed equals 3 to the power of m. From here, I'll go ahead and get rid of the fraction. If I bring this up to the top, it becomes 3 to the power of -3, which equals 3 to the power of m. From there, once we have the same base numbers, we can eliminate those, and then we know that -3 is equal to m, which is our answer. All right, if you have any questions, message me on Moodle. Till then, I'll see you guys next class.